Good morning, everyone. Welcome to our webinar. We're going to take just one more minute to allow everyone to get logged on and join us, and we'll get started very shortly. Okay, good morning, everyone. Welcome to our webinar. It's a few minutes after 10 o'clock, so we'll go ahead and get started. Welcome to our Ask the Lighting Experts webinar on energy savings potential from luminaire level lighting controls and network lighting controls. My name is Angela Pylant, and we appreciate you taking the time to join us today. I'm a senior lighting specialist with Evergreen Consulting Group, and we're going to talk about luminaire level lighting controls and network lighting controls. So right now, with LEDs becoming more and more standard, many of us are asking, what is the next generation lighting technology going to look like? How can our industry continue to drive energy savings? Connected lighting currently makes up only a very small percentage of luminaires in the US. A recent study from the Northwest Energy Efficiency Alliance, NEA, and DesignLights Consortium really details how it could be a big part of the answer to these questions and really represents the future of commercial lighting. Before we get started today, I just want to dive into a couple housekeeping items. So one, you have all been automatically muted as you entered the webinar, but we really encourage you to ask questions as we go through here. So if you look at that GoToWebinar panel, you're going to see the little question feature there. So use that as we go through today and send those questions our way. If we have the opportunity, we'll ask those questions as we go along. And then we certainly have time at the end of the webinar to answer any questions. We're also going to be sending you, after the webinar is complete, a follow-up email, and it's going to have the recording of today's session, a copy of the slides, and a link as well to download the research report that we're going to be discussing today. So today we're going to start off with an introduction to network lighting controls, and as well as luminaire level lighting controls, and then a brief background on the recent study that NEA did with the DLC. Then we're going to dive into the details of how the study was conducted and walk through those results. And we'll finish by discussing the findings and recommendations of the study, and then wrap up again that dedicated portion at the end for that Q&A. So please send us your questions. So with that, I would like to introduce our two presenters today. Our first expert is Chris Wolgamont, and he has worked in energy efficiency for over 20 years. He is a senior product manager at NEA, and his role is to engage with utilities, manufacturers, and distributors to bring new and tested products to market. Chris is also a certified energy manager and a certified demand-side management professional, and he frequently presents on the future of lighting controls across the country. He also serves on the Next Generation Lighting Systems Connected Lighting Advisory Group. So thanks, Chris, for joining us today. Next, we have Bhagwat Mohan, and he is a senior technical operations analyst at the DLC, where he focuses on network lighting controls programming. So prior to joining the DLC, Bhagwat served as a consultant at Eversource Energy, and he helped commercial and industrial sector customers uncover efficiency opportunities. and he has extensive experience with energy audits and energy savings calculations. So with that, let's get started. Chris is going to be kicking us off by sharing a little bit of background on lighting controls technology, as well as the study.
Great, thanks, Angela. Thanks again, everybody, for showing up and listening to us talk about some of these findings from this really exciting report. So the first thing we're going to talk about is, what do we define network lighting controls as, and what were we looking at? So we used the definition that the DLC uses for network lighting controls, which is a system consistent of an intelligent network of individually addressable luminaires and control devices, allowing for application of multiple control strategies, programmability, building or enterprise level controls, zoning, rezoning, using software, measuring, and monitoring. So basically, that's what we've defined as a network lighting control. Inside of that, the control strategies that are there are typically occupancy sensing, daylighting, high-end trim, or task tuning, synonymous with each other, and then they have some other stuff on top of that, that depending on the system that are available, that we define as non-energy benefits, which are sort of listed here on this slide, which talk about asset tracking, space utilization, energy monitoring, security, integration with BMS. Most of this we didn't get into in the report, but it's good to know that these systems are capable of that. So we looked at the overarching category of network lighting controls, and in this report we were also to break out luminaire level lighting control, which is on the next slide. The difference between luminaire level lighting controls and network lighting controls is basically luminaire level lighting controls is a subcategory of network lighting controls. And the difference being that it has a sensor in every fixture. So the general fixtures in the space all have a sensor that does occupancy, daylighting, task tuning, and everything in every fixture. A network lighting control system has one where a single sensor can control multiple fixtures. We found that we, as in NIA, when we started this second report with DLC, we're very interested in this granularity of data that comes from having a sensor in every fixture. And we feel like it adds to some of these non-energy benefits in a way that's very beneficial. It increases the amount of data and the areas it can see for that asset tracking or for the integration, plug load, space optimization, and demand response. So it does everything that the network lighting controls do. We just think that you get more information, so it does it better, may not be the right word, but in a different way. So those are what we looked at inside the report. And then when we go to the next slide, I think we're going to talk about just a little bit about a report that DLC did earlier this year, which talks about the interoperability of network lighting control. So this report, if you haven't read it, is a really good report, and it talks about the energy monitoring, the demand response, and the system integration capabilities of these systems, and how they could make a building more energy efficient, and not just the lighting, but the entire building. And so just wanted to highlight this real quick so that if you haven't seen this one yet, make sure you get it from the DLC website and review this one. So what did we do? The next slide will show in 2017, DLC did the initial energy savings report on network lighting control. And, we waited a few years, and at the beginning of at the end of 2019, NIA decided with DLC that we wanted to update the old one and see if we saw different numbers and if there was more buildings and have a better data set. The other goal was to separate out LLC savings from just straight NLC savings. And so with this new report, we were able to do that. We had an increased number of sites, almost doubled the sites. We more than doubled the manufacturers. We've had multiple building types. We even were able to add a building type, healthcare, as you can see. And we were able to analyze and split out Highend Trim from the other control savings. We couldn't totally split out the daylight and occupancy and separate those two, because not all systems have that capability, and we weren't able to get that kind of data from everybody. But we were able to separate out the trim and those two savings. So that's another thing that's in the report that's kind of an interesting thing finding LC. And again, like we said, we were able to split out LC. So I'm going to give you a really quick preview before we get into how it works. And so in the next slide, we'll see that the energy savings overall for all network lighting controls came out at 49%, which is really kind of consistent with what the number was from that first report. The first report, I think, stood out as 47%. So we're seeing very consistent numbers that show that, you know, basically 50% energy savings for network lighting controls, which is, you know, that's a really nice, it's a good energy savings. And you can see by this graph that there were some that were much higher, some that were lower, and we'll talk about that and how that gets there. For me, the next slide is what is even more exciting, which showed that the LLC version of this, so systems that have integrated sensors, had a 63% energy savings on average. So what we were seeing with those systems, which is what we have hypothesized and thought for many years, is that with that granularity of sensors, we're going to get greater energy savings with those. So those are those two sort of big numbers that are there, and I'm going to turn it over to Bhagwat now to tell you how we got there.
Thank you, Chris. So now I will touch upon the calculation methodology, the data outreach process, and share the results of this study. So initially, when we started the data outreach process, it was around the same time the California Consumer Privacy Act, or the CCPA, came into effect. So we had to research the CCPA and European Union's GDPR to ensure we were not violating any data regulations. After that, we reached out to 38 organizations whom we thought might have access to the NLC data that we could use in this study. The organizations included NLC manufacturers, utilities, research organizations, and some end users. So we started with our contact in each of these organizations and narrowed down to the right contact person. This was continued with several follow-up conversations where we determined their willingness to participate in the project, how much data they had and where the data was stored, and the level of effort required to retrieve the data. We started with 38 organizations, but ultimately we received data from 8 contributors. This was because we encountered some challenges, which was the lack of access to data. This includes the physical difficulty of downloading the data from the NLC system and also gaining authorization to share the data with us. The other challenge was the lack of data itself. In some cases, the NLC installations were too new, or energy monitoring was not enabled, or the data was not in a format that we could use for the study. We required time series data. Next slide. So this shows the summary of all the data that also includes the 2017 data of the 194 buildings broken down by the 8 building types across 12 manufacturers. We had the highest number of data sets from manufacturing sites, followed by office spaces. We also had a good collection from education buildings. We were hoping to get a better representation from warehouses and healthcare sites, but due to some of the challenges that I just mentioned, we could not include them in this study. Next slide. As for the geographic distribution, all the buildings were in North America. We had 35 states in the US, 5 Canadian provinces, and 10 installations in Mexico. So that's data sets from 3 countries. Next slide. So of the data sets we received, they were of 9 unique data formats and 18 subformats. Subformats is a derivative of the unique format with slight differences. So we have heard this term data set several times over in this session already. So what do we mean by a data set here? It comprises of two components, the time series data, which is the energy data reported at fixture, zone, or the building level. And the other is the static attributes, which is fixed data pertaining to each NLC installation. That could be the building location, building type, space type, and the rated power of the luminaires. So these two components comprises of a data set. And using this, we developed an inferred baseline and calculated the savings estimates against this baseline. So for each of the data formats, we developed a script to extract the time series data from whichever format they were in and converted it to a standardized form and then load it to our system to calculate the savings. Next slide, please. So here we are breaking down the savings by Highend Trim and the other control strategies. What is Highend Trim? It is the capability to set the maximum light output to a less than maximum state for an individual or a group of luminaires at the time of commissioning. So when you say 100% Highend Trim, it means the luminaires are operating at maximum light output at 100% rated power. If it's 80% Highend Trim, they're operating at 80% of the rated power. A human eye cannot perceive the difference between 100% and probably up to 70% Highend Trim. So just by trimming your lights down to 70%, you're already saving energy without feeling any difference in the light level. And in my opinion, Highend Trim is an underutilized capability that has tremendous energy saving potential and is relatively less dependent on building and space type compared to the other strategies. Getting back to the chart, the green region with blue stripes is the savings from Highend Trim, and the savings from other strategies is highlighted in the orange stripes portion. I should mention that the savings from other strategies was calculated against the inferred baseline with the impact of Highend Trim removed. So that would give us the accurate representation of savings from these strategies with no influence of Highend Trim. Next slide, please. So this is a chart we have seen earlier. This is a distribution of energy savings across all the data sets considered in this study. That was 49%. The highest savings was found in manufacturing sites, warehouses, and office spaces. As you can see, there's a wide variation across the 194 buildings from 2% all the way up to 91%. The term control factor and savings mean the same thing, basically. When you're talking in terms of control factor, it's a range between 0 and 1. It's the fraction of NLC energy saved, while the percentage of control factor gives us the savings. Next slide, please. This breaks down the savings by building type. Each box and whisker plot represents a building type, and the circles represent each building. As noted earlier, warehouses had the highest savings with 68%, followed by office spaces with 64%. Assembly sites had the lowest savings with 28%. Although if you take a closer look, you can see that in each building type, there is a wide variation in savings. This was a similar observation we made in the 2017 study as well. Next slide, please. Now looking at the savings attributed to Highend Trims and the other control factors. In the chart, the blue portion of each bar represents the savings from Highend Trim, and the orange portion is the savings from other strategies. And as you can clearly see, most of the savings in almost all cases was attributed to Highend Trim. The savings was 27% from Highend Trim, whereas all the other controls combined was 32%. And I would reiterate that the savings from other strategies was calculated with the influence of Highend Trim removed. Next slide, please. This chart, we look at the savings from the other strategies color-coded by building type. There was no particular building type that demonstrated tremendous significant energy savings. The saving opportunities was equal across all building types. This is because for other control strategies, they are more dependent on NLC installation, the configuration settings, like the vacancy timeout, is it 5 minutes, 10 minutes, or 15 minutes? And also it's specific to each building, like the user occupancy patterns and how much daylight you have available. Next slide, please. As Chris mentioned earlier, we were able to analyze the savings potential from LLC systems. Of the 194 data sets we had an even distribution of the data sets of NLCs with and without LLCs. So 98 systems were with LLC and 96 were normal NLCs without LLC. So taking advantage of that, we calculated and determined that the savings from LLC systems was 63%, whereas the savings from all the NLC systems with and without LLC was 49%. You can clearly see the savings from the LLC systems are dominating the energy spectrum in the higher region. Next slide, please. So taking a closer look at the LLC systems of the other control strategies, the Highend Trim savings was 37%, whereas the savings from other control strategies combined was 41%. This concludes my section, and I would hand over things to Chris.
Great, thank you, Bhagwat. One of the things that we saw in this obviously is really good energy savings, and so when we did the report, there were some recommendations. In this recommendation section, we didn't go through all the recommendations that are written into the report. We just picked out a few that we thought were highlights for it. So we'll just talk about a couple of those, and we'll, you know, if you want to know more, well, obviously you can look at the report on the other ones that are there. So first recommendation that we have is obviously the energy savings. So we've shown this slide a lot of times in where that comes in, but I think is the knowledge that this 49% is an average, but it's very site specific on how the energy saving is going to you know, appear. It all depends on the control strategies you put into place. You know, like Bhagwat said, Highend Trim, if you are very aggressive with a Highend Trim, you're probably going to see bigger savings than the 49%. If you're not very aggressive with Highend Trim, and it's not something that you can do because you need the full light from the fixture, or, you know, however that works, then you may not see quite as much savings on this. But there is a lot of savings to be had with the trim and with the occupancy and daylighting system. And occupancy behavior will also have some bearing on this. So that's kind of the first finding, is that, you know, there is lots of savings, but it is really based on what the building is being used for, what type of use the lights are doing, and how aggressive you can get with your control strategies when it comes to that. So the second finding that we're going to highlight is something that we've, you know, sort of talked about before, is the difference between NLC and LLC when it comes to the energy savings. You've seen this information in a different graph earlier, but I like this table a little better. It makes it a little more clear on where that savings was and how it appears, right? So the big thing here is that you can see that the average savings for LLC was 63%. And that for just straight NLCs, it was 35%, with the overall all NLCs, including LLC, is 49%. So, you know, that's a pretty big difference when you start looking at just the straight network lighting controls versus luminaire level lighting controls, 35% to 63%. I know for us in the utility world, we sort of define and look at things, and we see that systems that have two types of control strategies, so occupancy and daylighting, usually end up in that 30 to 40% range in our calculations, which is right where NLCs are falling in there. So, and that's including, as you go across, you can see the Highend Trim for those network lighting controls is pretty minimal. It's only 17% compared to 37% for you know, network lighting control. So that infers and tells us that we can get better energy savings because we can get more granular with the lights and turn individual lights down or smaller groups of lights down and see higher energy savings with that. But it also shows that on the other control strategies, you're looking at 22% versus 41% when it comes to the occupancy and daylighting systems as well. So you're seeing not just the trim being the difference in those savings, but you're also seeing the other control strategies definitely having better energy savings for the systems across the board. So this is something that we, had hoped, and as NIA, we had hoped because we were really, kind of pushing for the LLC type systems. But the one thing that, I will say this, and is the asterisk to this is the first time it's really been separated out, and it's a good database, right? 98 systems, but we really do need to do a little more study just to confirm and collaborate this energy savings. But I know that we've done some small reports and small studies on, small building sets and come up with the same type of numbers. So I'm comfortable with knowing that these numbers are pretty accurate, and that LLCs do promote greater energy savings. So that's the second finding. The third finding is just, for me, it was just a very interesting finding. I don't know that it'll be of great interest to a lot of people, but one of the things that we look at is that as utilities and in this business, we've always looked at sort of assigning hours of operation for buildings on average, saying that these buildings operate X amount of time. So like a school, we could say operates 2,800 hours a year or whatever. And that's pretty standard across the country, is to, picking these numbers. When we did this, we went through and we got energy, the hours of use estimates from a whole slew of different areas. So from Illinois, Mid-Atlantic, New York, the Northwest, and came up with these numbers. And you can see that they're all, in close proximity to each other. But what we found with this was that in these systems that we were monitoring, some of these 196 buildings, that they had higher average occupancy hours than what the average use was according to different regions. That we were seeing numbers much higher than that. Now, what that means, or doesn't change much when it comes to anything, but it's just interesting to see that we're seeing longer hours in all these building types. So that's pretty interesting type of stuff to just understand what's going on. So those were the three findings I was going to highlight. I think the other thing that we wanted to talk about real quick and just sort of touch on, it's not a finding, but I think it's important to understand, is some of these non-energy benefits and how they tie to the energy savings as well. Some of this stuff that we're talking about, these systems are capable of, which we didn't go into in the study, which was, like the energy monitoring side or the demand response side, or even having some of the products be able to do space utilization or tracking, or, some of the stuff that we've, highlighted earlier that these systems are capable of. Sure, they add to the allure of these systems, right? They add to the capabilities. If you can get energy savings that are as high as what we think we're seeing and we're seeing in this report, and you can add those non-energy benefits to your building as well, it sure makes these systems a sort of a win-win for the building, right? You get the ability to have a really great energy system, plus you get to have the ability to be more flexible, the ability to track your energy, to track how the space is used, and a lot of stuff that doesn't affect your energy bottom line, but it can affect your business bottom line. So with that, I think we're ready for some questions.
Excellent. Thank you, Chris, and thank you, Bhagwat, for sharing the results of the study. So we do have a couple questions coming in. The first one was, what was the most unexpected result of the research results?
Let's see, most unexpected. I think it is not shown up in this report, but I think the most unexpected for me was some of the individual building savings numbers that came up. And I may not quote it quite right, but like in office space where LLC, they came up with an energy savings number for the general office building of like 73%, which is like huge. I didn't expect to see a number quite that big for office. We hear about that number pretty regularly for like warehouses, where you have a lot of space where you can turn the lights off constantly because there's nobody in the space picking up something in the, that shelf or whatever. But I think for me, that was one of the biggest surprises, was to see that the average energy number for a office with LLC was above 70%.
Thanks, Chris. Okay, let's see. Our next question is, have you been tracking failure results, or do you have a feeling for some of the reliability of the components?
I can tell you that we haven't really tracked the failure results, and in this report, I don't think there's anything on there about that. A lot of these are relatively new systems. I know in the Northwest for NEA anyway, we do, we don't formally track anything, but we do keep a contact with the ones that we've done case studies on, and we don't have a lot of failure rates that we see. I think that's one of the things with LLC, which makes it nice, is that because you've got such granularity and you've got so many extra sensors, even if something does sort of fail, one fixture fails or whatever, you've still got all the others with this network of, whether it's a mesh network or whatever, that you're not going to see the system fail, and so that helps with that. But it's also one of the nice things about a lot of these systems is they do some sort of maintenance type of stuff where you can tell which systems are failing through the interface. So you can tell if something's not working right. Some of them even have predictive capabilities where they can say, hey, this isn't operating the way it should. You might want to take a look at it, which can help sort of reduce the amount of failures. All right, I think you're on mute. There you go.
Yeah, this is also something we took care of in the initial phase of the data collection to identify any irregularities in the data. So we see a bunch of numbers and random bunch of zeros, there's been a component failure. So those were things that we straightened out before including them to the study.
Excellent. Thank you both. I think this next question, I'll leave it up to either of you to answer. They're saying that they noticed a large difference between the Highend Trim savings that was attained between Luminaire level lighting controls and network lighting controls. So what do you attribute that difference
to? I think it's the fact that you can go down to the fixture level with LLC versus a group level with NLC. So by that, I mean, if you have a lot of these, you're not able to Highend Trim each fixture with the network lighting control system, or you don't go down that low because the sensor is controlling multiple fixtures. With LLC, you can go down to that individual fixture and change it to almost be personal control. LLC doesn't mean personal control. That's not the point of LLC. We're not giving everybody the control of the fixture above them or close to them or whatever. But what it does do is it allows you to go to the lowest end point of the system, which is that fixture at the end, and you can control it. And, you know, based on a lot of different things, right? Unfortunately, age has a bearing on how much light you need in the space. So, you know, maybe this space has older people like myself, and you need a little more light, so you aren't able to trim it as much. Or it could be younger people, and you can trim it a ton because they don't need that light. So I think that that's a piece of it. I think it's a piece of the research we need to do to find out exactly why that is. Did they overlight the space with the fixtures, and could they have done better with the fixture design? I mean, that's a piece of it probably as well. But I do think that the fact that we can go to the individual fixture level with the trimming does make a difference.
Yeah.
So the next question is, have you seen or aware of any research that indicates that having these type of controls extend the life of those components within the system?
You want to take this one, Pegwad, or do you want me to?
Sure. In terms of controlling and the lifetime of the components, of course, the solid state systems itself are not impacted by the frequency, but by using the different control strategies, they definitely do help in identifying beforehand the battery life, or with the rich data that NLCs can provide, the lifetime can be used for security and signaling. So that's really helpful when you're looking at luminaires that can be controlled versus just independent luminaires.
I think the other thing is what we do hear and see, and obviously nothing's been in long enough to prove this, so it's all a little theoretical when it comes to this. But when you do the high-end trim piece, you're underdriving your driver, which can add to the length of time that driver is life expectancy, because you're not driving it as hard. If you drive that driver at 100%, you know, that's what they sort of track it and say its lifetime is based on 100%, you know, usage. By doing some of this high-end trim, you're underdriving it. So the theory is that you'll extend the life of that driver, which is the sort of the weak point of the fixture, right? In that. So I think that it's definitely possible that we can see these systems be a longer life. But much like anything that's LED, where we can say life expectancies 7,000 hours or 70,000 hours or 100,000 hours or whatever it is, until we get to the point where we start seeing that amount of time, it's a little tough to you know, put a stamp that says they're definitely going to last longer because of this. But the hopes is that's the case.
Great, thank you both. Okay, so I have another question coming in here. These are great questions, everyone. Thank you so much. What was the study participants' experience and opinion of the complexity of their systems and the user ability to use those systems?
Mm-hmm.
I don't know that we did I'm not sure that when we did this report, there was a lot of that kind of data that we gathered. We didn't really talk to them about how they liked the system. It was strictly about
it's more about
use. So
more data focused.
Yeah, so I'm not sure that we can answer that as you know, in a way that anybody's going to be happy, because I don't know the answer really. We didn't really talk to them about that, unfortunately. I think that is something that when we go at this again, maybe we can add that to the next time we do the study, right? I mean, I think that's a great question to ask. I also think that it's a little sometimes it's a little tough because we didn't always get to talk to the building itself We got the data from multiple data sources. So sometimes we got it from the manufacturer, sometimes we got it from a utility, sometimes we got it from the building type, the building itself. So we weren't always able to talk directly to the end use customer when it came to this. Sometimes it was we got the data in a different manner than that. So, but I mean, I would love to know. I know in our case studies, we always talk about that for those, because we want to know what their opinion was. One place, just one other place that I know that I work quite regularly is with a group called NGLS, Next Generation Lighting Systems, and that's one of their focuses is the install, the complexity of it. What do people think? How hard is it? How do the manufacturers adjust for that? How does that work? So, there are a couple other studies out there that definitely work towards that. The goal is to have them not be super complex, right? I mean, it'd be a lot, especially with the LLCs. The hope is that it's almost out of the box, right? Because you've got the sensor in there, and all you got to do is wire it to power, and the system should just automatically give you occupancy and daylighting. It may not be the greatest setting for you, right? It may not be what you're after when it comes to programming it and commissioning it, but with the LLCs, because every fixture has that sensor already in place, if you didn't do a single thing to it, you would have at least some form of energy savings right out of the box, which is a simplified version of that. And a lot of these systems are using phones and apps, which hopefully make it easier. Sometimes you see them make them a little more complicated because people don't understand how they're doing it. It's not what they're used to, that kind of thing. But I think over time, it definitely is going to make it easier, and people are and less likely to turn them off. I think that's the other piece, is right, is because you can sort of go down to that fixture level and down to that end level, that you can make it so people are less likely to complain about the controls, because it's not a control that everybody has to deal with on a mass floor basis. You can take it down to a level where maybe you don't get the complaints, and we stop seeing black tape over the sensors when you go into the office space. So.
Thanks. Yes, I have seen that a few times in my career as well. So another question's coming in here. Do you believe the savings from the high-end trim indicate that some of those systems were overlit or poorly designed?
Not sure we had data on that, because that would depend on the building codes and the building type and the location, the state as well. So the systems the buildings that did have aggressive dominating high-end trim savings was definitely from aggressive high-end trim, whether it was LLLC or systems without LLLC.
Okay, thank you. Bhagwat, this question is for you. You mentioned high-end trim being underutilized. Was that specifically reflected in the data?
This data was in fact supportive of the savings potential of high-end trim. So that is just my personal opinion, that it is less likely to be dependent or affected by the building type or the space type. So like I said, you can just trim down your lights to 70%. You're not going to feel any difference in the light level, but your energy meter does feel the difference. It's going to be, of course, consuming less power than the rated power.
Thank you. Yeah, there's a lot of potential for savings there, isn't there? I think we may have already answered this with one of the previous questions, but someone asked, was there any post-occupancy surveys done to help determine occupant comfort or adoption of the control systems?
I'm sorry, Angela,
yeah, and I think
you broke a little bit. Could you repeat that question again?
Oh, sorry. I think we've answered this already, but just a question about, is there any post-occupancy surveys to determine occupant comfort and adoption of the control systems?
That's something
Yeah.
we should. I think I heard Chris.
He's still there. Oh, I was just going to say, no, we didn't do anything with that, but we definitely should.
Yeah, that's something we should consider for the next time around, like user satisfaction survey. It's also challenges with retrieving data from the users versus utilities or the manufacturers itself. That's with all the data privacy acts coming into picture. So that was one of the challenges, and it was getting really tricky to retrieve the data from the consumers versus the NLC manufacturers itself.
Thanks. I have another good question here. This person saying they're not a lighting engineer. Are network lighting controls currently a requirement in SEC or WSEC building codes? Are either of you familiar with that?
So none of them are a requirement in the building codes that I know of. In IECC 2018, LLC is a optional path inside that. So you can use LLC and it automatically meets the IECC 2018 code. So you don't have to do all the design work of figuring out your daylight zones or your occupancy areas and that kind of stuff, because it's automatically covered with the LLC version of it. As for ASHRAE 90.1, I think that the way that there's no path for either one of these where they call out network lighting controls or LLC, but what they do is all of these will meet those requirements, right? Because especially with LLC, if every fixture has a sensor and every sensor has daylighting and occupancy, you don't have to worry about daylight zones, because you've got your daylight zones covered. Not only are your typical daylight zones, daylight 1 and 2 zones have daylight sensors in it, but you actually have daylight sensors in the core area as well. And from some studies that we've done separate from this, we actually see that there is minor daylighting savings in those core zones with that daylight energy, which could lead to be one of the reasons why you're seeing bigger energy savings with LLC than NLC, because you've got some daylight savings in that core, even if it's only 5-6% in that core area. It's still savings that nobody's getting right now if you don't put a daylight sensor there. So that's what I know of for code itself. Specific regions are obviously, it's a little different if you're in New York or Chicago or Seattle. Definitely follows that, and Seattle has a path for LLC in it right now as well.
Excellent, thanks, Chris. Okay, we just have great questions coming in here. Okay, the next one, what are the person hours required to operate and monitor such a system that has that complexity? So it's not a set it and forget it type of system, is how the question is asked. So
I think I understand. Are you talking about it? So you're talking about, like, do you need to have somebody monitoring this 24/7 or during the work hours or whatever?
Yeah, kind of sounds like maybe operate it and then monitor,
Yeah, I don't think that's totally necessary. I mean, I don't think I know that we haven't really ever done a study on how that works, but from my discussions with facility managers that have installed this, and it depends on the system itself, right? So some of them will have the capability of sending you an alert if something's wrong, but for the most part, you're just sort of it's not really any different than the lighting system you currently have. You know, you're just maybe once a day or maybe a couple times a day at most, you're just sort of checking it out. If you're really diligent and really trying to save energy and monitor what your energy use in the building, maybe it's a little more aggressive and you're spending more time on it. But I don't think it's a super time-consuming thing to do this unless you're specifically looking for a reason to be doing that, right? If you're like, I've got an energy goal of saving this much, and so I'm going to be on top of this for doing that. Otherwise, I think it's almost a set it and forget it because of how you do it. You just check it when you want to. And again, it depends on the system, right? You get one of the more advanced systems, they'll let you know if something's wrong, and then you don't have to monitor it. One of the simpler systems, maybe it's just gonna, it doesn't run any different than the controls you have on your lights right now. How much time do you spend monitoring that type of thing?
Yeah, it's also important to ensure that the commissioning is during the commissioning process, it's error-free and accurate. So some systems need manual entry using the lookup table. So need to make sure that that is done correctly to reduce any errors.
Thanks. A couple more questions coming in. We have a few more minutes. So this one specifically for Chris, based on the data that you're seeing, should the utilities consider adjusting their hours of use?
I think it's something they should look at. One of the things that I do think is that a lot of the data that is being used by everybody, not just the utilities when it comes to hours of use, is relatively old. It's data from, I want to say 15, 20 years ago. And there hasn't been a lot of new studies on what the hours of operations are, as we move forward in time, right? So I think this is just one of those things that it's an interesting find, and I think that it's worthy of somebody doing some research on what, if there is a big change in what the hours of operation are based on, since the last time something was done. So I wouldn't use this study to say move it right today, but I definitely think it raises a little bit of a flag that says we should probably look at it going forward, and maybe we should be looking at it different. Coming from the utilities perspective, if the hours of operation are greater, then the energy savings that they can claim is greater too, right? Because they're set inside a certain regulation that says, oh, they can't claim more than 2,800 hours. But if it's really 3,500 hours, there's bigger savings that they could claim, which as a utility they would love to be able to do. But it's also more reality for the business customer too, if they get the hours closer. Obviously, the best thing in the world is to know actual hours of the time of the building versus the the estimated hours. But so.
Okay, thank you. And one question for, I'd like to hear something from you both on this. If we have a facility manager or a building owner decision maker on the webinar today, what's the key takeaway that you would like them to leave with today after attending? Like the most important thing.
Firstly, to pick an energy system, identify your building needs. That's really important because there are a wide range of systems available in the market, from simple room-based systems to comprehensive network solutions. So do you want your system to integrate with HVAC and BMS? Does your building have BMS? Do you want your lights to communicate and exchange data with the BMS? Because NLCs are just beyond just energy savings. They have tremendous non-energy benefits too. Like it impacts productivity, it provides user comfort, and on integrating with external systems, you can reduce operational costs of the building. And NLCs are also rich in data. They could provide information on occupancy patterns, temperature, humidity, carbon dioxide levels. I think these information would be really insightful for building managers to streamline their building infrastructure more efficiently. So there are a few things to consider. Make sure you're picking the right system that meets your building needs. And if you're having an ongoing LED upgrade project, do not neglect lighting controls. Go for it.
Yeah, for
I
sure.
think Alekio, the last thing the last thing Bhagwat said is probably the most important to me is that we're probably seeing, if you're doing lighting today and you don't put these controls in, you're probably not going to get these controls in for a very long time. And, you know, if you do it after you've done an LED system, there's less help for from the utility side, which everybody should be asking their utilities for the incentives with these type of systems. So it's really important that if you're going to be doing lights, to put these systems in today, because it's going to cost you a whole lot less today than it will 2, 3, 5 years down the road to do it. So.
Excellent. Thank you both. See, I think we have one more question before we have to wrap things up here. Well, actually, it looks like we were able to get to all the questions. So that's excellent.
Awesome.
Okay. Well, thank you everyone for joining us today, and thank you for all of the questions. That was excellent. And thank you so much to both of our presenters for giving us your expert insight. That was a great webinar. Like we said in the beginning, if you're interested in learning more, I really encourage you to download this report, and you're going to get that link in the email that we send out to you. Again, and as a follow-up, we'll be sharing this recording. We'll share the slide deck so you have this information, and really encourage you to go to nia.org and download this report. So with that, I think we will let you all go and give you a few minutes back of your day. Thank you so much. We hope you all have a wonderful day.
Thank you.
Thanks.